Hey, we're going to review functions and graphs, and we're going to start off with function notation here. And I've got the example f of x equals 3x squared minus 2x plus 5. And I just put this here to make sure you're familiar with the function notation, the different parts of it. So f or f of x is the function name, and f of x stands for the output. Sometimes you call that the range or the y value. Of course, x is the input value, that's the domain. And then the actual function there, 3x squared minus 2x plus 5, is how things are calculated. But if we want to actually find a value, for instance, f of 7, that means we would take that 7 and plug it into the function everywhere. So where we have 3x squared minus 2x plus 5, that would be 3 times 7 squared minus 2 times 7 plus 5, which would eventually give me 138. So more or less that's an x of 7 going in and an output of 138 coming out. So that's like an xy point on a graph, and that should be something you are familiar with. The next topic for review real quick is intercepts. And intercepts can occur on any type of graph, but the main things to pick up here, X intercepts are on the x-axis, and that's when the y value, which is f of x, is 0. And y-intercepts occur on the y-axis, and that's when x is 0. So really quick, if I drew a little graph over here, let me change colors here a little bit. The x-intercepts would be on the x-axis, and that's why y is 0. You don't go up or down. And the y-intercepts happen on the y-axis, which is when x is 0, so you don't move left or right. So that's the reasoning behind what you would assign 0 here. So the example we'll work real quick is f of x equals x squared plus 7x plus 6. And the first thing it says is to find the x-intercepts, and that happens when y is 0. So we will let y equal 0 or f of x equals 0. So that gives me 0 equals x squared plus 7x plus 6. This is a quadratic. I can solve those a couple of ways. I'm going to factor it. This factors into x plus 1 times x plus 6. And remember that I can make that into two equations. X plus 1 equals 0. X plus 6 equals 0. Solves. X is negative 1. X is negative 6. So the x-intercepts are negative 1, 0 as a point, and negative 6, 0 as a point. So as far as x-intercepts go, those 2 points would be on the x-axis of that function that I have. Okay, slide down a little bit, maybe not that far. So to sneak the, let me cut this off and go a little bit slower. I don't know why it wants to be so dramatic. Okay, here we go. So to find the y-intercepts, remember that we're going to let x equal 0. And if we do that, we can take our function. Please don't reset everything. So we can take our function, which was x squared plus 7x plus 6. Let the x's be 0. So when we plug 0 in for x, we get 6. So that y-intercept would be 0, 6. And that would be on the y-axis. Okay. So letting the x, to find the x-intercepts, let y be 0. To find the y-intercepts, let x be 0. Evaluate or solve. Okay. The next thing we want to talk about are the increasing and decreasing intervals of functions. Very simple thing. So a function is increasing when it's going up from left to right. So my little graph down here, which is a little polynomial, as we move from left to right, we find this little region here where it's going up from left to right. So maybe I'll say it's increasing from -2 to 2, and that's an x interval. So just in case you're getting confused with a point up there, keep in mind that this is the same thing as -2 is less than x is less than 2. So that's an interval, not a point. The notation looks the same, but in the context it means something completely different. But it's also increasing over here. It looks like it's starting around 4 and going on forever. So we can also say we have an increasing interval from 4 to infinity, or you could write that. You don't need both notations, but you could write it as x is greater than 4. Okay. Now if you want to talk about the decreasing intervals, that's where it's going down from left to right. So the function value is the y, and the y is decreasing right here as we move from left to right. And that interval is from -infinity up to -2. So we could write that if we like, and inequality notation is x is less than -2. It looks like it's also decreasing from 2 to 4. Okay. So from 2 to 4, and if you wanted to write that as an inequality, as an inequality, you could go -2 is less than x is less than 4. You don't need both the inequality and the interval notation, but just to make sure you understand it's not a point. And keep in mind, as we move from left to right, doesn't matter what these arrows are doing, because they might not be following the graph from left to right. They might be following the y value, okay, which is up and down. So even though both of these arrows are pointing up, as we move from left to right, the first little segment is decreasing because the graph is coming down as I move from left to right. So we're moving across the x-axis and deciding if the y is increasing or decreasing. So just keep that in mind and be careful. All right. Oh, I forgot to stop the video.